third-party integrations are honestly the best thing to hack on. That's completely unbiased. No, but seriously, services like AWS are such a pain in the arse to set up, and they can lead to so many vulnerabilities. Developers will often not read the documentation, and that's completely understandable because the documentation for AWS could actually be compiled into a 500-page book. It's just so long, and no one ain't got time to read that. So that's going to cause vulnerabilities which we can exploit. Since services like AWS are often used to access or store user data, this is great, as a misconfiguration here could often lead to a high or critical vulnerability, which I've often seen in these third-party services. I myself have recently got a $5,000 payout from an S3 misconfiguration, very similar to the previous one that I found on Asana for 2,500, which has been disclosed, and I'll probably put a link in the description because it's pretty similar. But today I want to focus on a different kind of aspect of that misconfiguration, which is how features can interact with each other, features that utilize Amazon S3 specifically, how they can interact with each other to create the perfect environment for a PII leak or for some kind of high or critical vulnerability. And I've seen this setup very, very often on platforms that I hack on, and it's very rarely that I'm not able to find some kind of misconfiguration on them, which is really good. And I want to pass the knowledge on to you because this has been making me a lot of money recently. And as always, I'm going to have a live example. I've updated the S3 labs from the last video, so it's up again on my website. And I'm going to start with the high level explanation, and then I'm going to hop into that live example as always. Okay, just to recap, what actually is an S3 bucket? S3 bucket is just a place where a website can store its data. Website, application, whatever, can just store some kind of data. It's called a bucket. You can visualize a bucket because you could just put information in it. That's a very nice analogy. Now, it doesn't work like a normal file system though. It's not an actual Linux directory. These keys are kind of a little bit fake because they're just like the entire name of the item, right? So if I want to store this thing under assets, I have to create this key /assets/user.pdf, and this like /environment. And there's no path traversals here because this is not a Linux operating system. So this key is actually completely valid in S3. This is a real key. So /environment // will work as an actual key. That's why path traversals on S3 are a little bit dead. And there are directories. So there are directories like /assets. We can define that as a directory. But in the recent S3 kind of update and the newest API, listing is not enabled by default. And that's going to be important for some of the escalation that I'm going to show you later. And so if we do /assets, it's not going to list everything in assets. So that's generally not going to happen anymore. And yeah, so as a website, we can store user data. Why would we want to store this in this bucket? Why not just store it on the server? Well, this prevents us from having to do a lot of things. One, it's a lot cheaper to store it on S3 versus our own servers because S3 is optimized for storing data, while things like Linux are generally optimized for running things like commands. You can't run anything from S3, it's just a storage place. So it's usually cheaper to store it on S3. It also prevents a lot of file upload vulnerabilities, like processing, like storing something somewhere. Maybe there's like a path traversal there, like a zip slip or something like that, that could lead to the server, overriding data or whatever. But storing it on S3 completely mitigates that because, as I told you before, there's no path traversals on S3. So that's very nice and just very convenient from the developer's point of view. There's many other reasons, but that's kind of the main few reasons why it's just cheaper and it's kind of safer to do it. And you'll generally see S3 as this kind of URL here. You'll see the name of the bucket, the region it is in, and then this .s3.amazon AWS domain. It's kind of look a little bit different, and I think the region is actually optional, so this should work. And the name of it is just the name of the bucket that they give it. I think all buckets are actually publicly accessible from what I know. Even if the bucket is not intended to be accessible by the public, you will be able to reach this domain, but you will get an access denied request. That's because to access data in the bucket, you have to have the actual key for the bucket, the AWS credentials, in order to access it. And you need to mint some kind of signature to access data in the bucket. So you can't just visit this URL and like get all the data, right? So it's not how that works, unfortunately. So the data is private, but it is exposed in the public domain. So if you ever want to verify a bucket exists, you can try and access the name here and then .s3.amazon AWS, or you can fuzz some buckets and stuff if you have a vulnerability that allows you to access different buckets, like I had at some point. What I've actually been seeing a lot more recently though is instead of developers allowing access to the public bucket domain for uploading files, they instead create a reverse proxy on their own server, which hits the bucket in the backend. So normally they'll have a domain like, say like s3.example.com, like this. And all that will do is this s3.example.com domain is going to forward that to the actual bucket itself. So whatever the bucket domain is, like example assets.s3.amazonaws.com. And that kind of prevents the bucket from being exposed, potentially enumerated and stuff like that. And it also feeds into a lot of CloudFront integrations, which I'm going to speak more about in the next video on S3, and something that found me a very nice vulnerability. But CloudFront is like a web application firewall managed also by Amazon, and it can be configured to work with S3 automatically and sort of take out a lot of the hassle of configuring it, which can be very nice for developers. So I've seen this like kind of reverse proxy setup a lot nowadays, and the telltale mark for this will be if you visit a company's domain, so a non-Amazon AWS domain, and you see S3 bucket like responses. It's like server will be Amazon S3. You'll get like the classic Amazon headers in there and like the request IDs and stuff like that. That's a telltale sign that they're using the reverse proxy setup and that you are actually hitting a reverse proxy. And you're hitting a reverse proxy that's forwarding it to the bucket. The bucket should still be accessible actually under the name. So if you can enumerate the name, you might still be able to access the bucket and see if something's misconfigured. Okay, let's say we have a very common example. We want a user to be able to upload a profile picture to S3, which is then going to be displayed by the website. How can we get the user to upload things to the S3 bucket? Well, the first kind of way, the kind of like stupid way to do it, is called like the direct way, or like the direct flow, which I called it in this example. So we see how we have the user, the site, which has the AWS credentials, and then we have the actual S3 bucket itself. And basically what happens is that the user will upload their profile picture to the server, then the server will upload the profile picture to the S3 bucket. That's about as simple as it gets, right? So the user doesn't even interact with the S3 bucket. The user might not even know the S3 bucket exists, or maybe they don't even know that the server uses S3 for this in this case. And this is kind of stupid. Why is this bad? Because it kind of defeats the purpose of S3 to begin with. Like first, you've introduced all the file upload vulnerabilities by allowing the user to upload their own files, and two, you've just created a lot of performance issues because on the network, the user has to upload this profile picture to the server. That means the server has to download the whole profile picture, taking up like 20 megabytes per second or something like that of internet. Once that happens, the server has to then post that to the S3 bucket again. So that means that it has to download 20 megabytes and post 20 megabytes for every single user. That's pretty wasteful on the server side. And it reintroduces a lot of these file upload things as well. So we kind of don't want to do that. We kind of don't want to have the server downloading these files because it defeats the point of the S3 bucket to begin with. So we kind of need a way for the user to be able to upload their files to the S3 bucket without going to the server, but we also don't want the user to be able to upload it to whatever directory they want to, because that's not good, because they could overwrite files that are used by other people. Like for example here, if the user could upload their profile picture to any directory in the S3 bucket, so any one of these paths, they could just find another user and upload their profile picture to that user's like directory, and the website would be like, the website will just load that profile picture, right? So that's kind of like an IDOR type thing would happen. And so we want to find a way to where we can have the user upload their data to the S3 bucket, but basically prevent them or limit them to specific kind of parameters or details. And S3 has a way to do this, and it's called a pre-signed URL. This is kind of the pre-signed URL flow. So first, the user makes an intent to the server. So the user says, I want to upload a file, essentially like to this directory or whatever, with this name, and like it provides like details about the file. The server will then, without downloading any files, it just receives this intent from the user, will then go to the S3 bucket and say, I want to give the user permission to upload a file to this directory with like this content type, these parameters or whatever. Then what will happen is the S3 bucket will return some credentials, and it'll be like, okay, give these credentials to the user. These are temporary credentials that have an expiration date. They always have to have an expiration date. And that will only allow the user to upload to this specific directory inside of like my S3 directories, right? So the server will give this kind of signature to the user now. So the signature will now go to the user. And then the user will, with that signature, will make a post request to the S3 bucket with the signature that it's allowed to upload to that directory and the data that it wants to upload. And the S3 bucket will verify that and say, yep, that's all checks out. Then we're going to have that file. And you can see that this is already a lot better, because instead of posting the entire file twice, we don't post anything to the server. So this doesn't even have anything to do with the file. And all the server processes is this user intent, and then the signature is sent back by the S3 bucket, and then everything else is outside of its own control, which is really good on performance. But you can see how this can be misconfigured, because this is pretty complicated. And there's a few ways in which this can be misconfigured. So one may be the intent of the user includes the directory they want to upload to. So maybe the user can tell the server that it wants to upload to a directory that it shouldn't be able to upload to. And when that happens, the server will issue valid credentials, and the attacker could upload to someone else's directory anyway. So the way the server parses that is going to be important for us. The second thing that can happen is maybe the server issued the wrong credentials. So the credentials are overprivileged, or maybe they gave credentials to read a file, but they were actually supposed to give credentials, they gave credentials to read a file, but they actually accidentally also included the credentials to modify a file. So obviously that would be a problem, because if, for example, with the same flow, you had the user reading another user's profile, then if the server accidentally gave them the user credentials to modify their profile, that again leads back to the IDOR scenario. So we need to be careful of that as well. So these are kind of the main vulnerabilities that exist. And, the server could be doing this a lot. This is a very common flow for S3, pretty like standard layout. So there could be a lot of features interacting with each other, and they're often stored on the same S3 bucket as well. Now, how do you know when you see this flow? What kind of indicators are there? Well, the main one is when you see a response type like this when you want to upload a file. This is a response I took from Asana, the S3 bucket that I was mainly looking at. And this is kind of what tells you this kind of large response with these Amazon type parameters. So this policy one is the main one. This policy will tell you what you're allowed to do with the credentials that you just got from Amazon. The S3 path is where the server has restricted the upload to. And then there's a lot of other like Amazon token credentials or whatever, like signatures, which don't really mean anything by themselves, but the S3 bucket will check to make sure they're correct. And usually it's a signature of the policy. So the policy is like signed and stuff. And the policy will look something like this. I come back here, where you have all these like Amazon metadata kind of stuff. There's always going to be an expiration date on this. The reason is because with these pre-signed URLs, they could end up getting like cached by like crawlers and stuff. So they usually have to have an expiration date so that someone can't just crawl your data off the S3 bucket. Because S3 keys are not private, I'll say that S3 keys are not private. S3 buckets do not conceal the keys for the objects, and they are absolutely able to be stored on web crawlers and stuff. So I'm going to show you a way that we can escalate vulnerabilities in the next example. But this is usually what it looks like. So you'll have usually the bucket, so the bucket that we can upload to, the credentials, the key is an important part as well. So this is where we can actually store our bucket. And for most websites, it's going to be pretty ugly. These are a lot of user IDs and like randomly generated characters, which is good because you want to obscure the keys as much as possible in order to kind of prevent the misconfigurations there. And then you'll have a few things like the content type, which is going to be there, the range, content dispositions, just basically anything the server wants to include. And then this thing, which means that the file is private, so we can't upload a public file to the bucket, which could be bad because then some random people will be able to read it and stuff. And yeah, this is mainly the policy. It's going to be pretty standard, but you want to have a look at bucket, so what bucket we can upload to. Maybe there's accidentally like a testing bucket or something in there, and then just the actual key itself, so the key that the server has specified for us, and see if any of that can get tampered with. And this is usually going to be sent from like I think I get maybe like a post request or something like that, and it's going to return this kind of stuff to us here. And these are for submitting it. The signature for reading a file is usually a lot simpler than this. This is for the uploading of a file, but it follows the same thing where it usually has some kind of policy, a signature, and like a key or whatever that we can read. And that's mainly what is going to give away that this is an S3 bucket. So I hope you understood all that, and I want to hop into a live example now where I'm actually going to demonstrate a real misconfiguration on an actual S3 bucket. Okay, this is the live example for today, which is going to demonstrate the misconfiguration in the S3 bucket. And I set this up, small platform with Cloud Code. I won't lie, I set this up with Cloud Code because it was a lot faster. And it's all PHP and stuff because this is my Bug Bounty Lab website. I am working on actually updating this website to be a lot better. I'm working on a kind of Dockerized system instead, where I can have different frameworks running. Right now I mainly have PHP running, but that's obviously a bit old and I don't really want to keep running that. So I'm going to work on a way to change that and actually add in Docker containers. Stay tuned, I'm going to change this lab website a lot. But if you want to access this, and I highly recommend that you do this before you actually watch me solve it, try and find it yourself, try and find a way to enumerate this S3 bucket and find keys for things that you shouldn't be able to find keys for. And the way you can do that is you can just hop on jacobjn bugbounty.de/labs. You can see I've renamed the labs a little bit because before I think the names were a little bit confusing. So I changed it to actually reflect what the vulnerability is. You can see here the lab called S3 attacks, which was modified very recently. We can go into here, and this is what it's going to look like. And this is what this basically reflects is kind of like a just standard like SaaS website, where often you're going to be able to export data, because for organizations they often want to export data like activity logs and stuff, like the amount of people in a team or something like that. So they're all data centric nowadays and shit. So they have like this option to export to CSV. And what better way to export that when with S3 buckets, store that data in an S3 bucket, which is often what these companies do. And then the second kind of feature here is the profile picture, which 99% of services out there will allow you to set a profile picture, and they often use some kind of cloud storage for that, which more often than not ends up being an S3 bucket or like Google Drive or something. I don't know. They use different things, but either way, these two features both rely on S3. And what's interesting is that we're going to go into it now. They often use the same S3 buckets as well. So with data leak in one of them, we'll hopefully expose the whole bucket. And I'm going to show you just how that works. First, I'm going to try just exporting the CSV. I'm going to actually turn on Kaido before I do that. So I'm going to turn on Kaido. Then I'm going to export the CSV. It's going to do some loading. So we'll see what's happening here. So it's posting to export CSV/PHP. I'm going to send it to the repeater. We'll see what happens here. Just close this tab. And we get some kind of download URL. So I'm going to close this page, go back to the replay tab and see what happens here. So this is not an S3 Booker response. So we see this is not an S3 Booker response, which is interesting. We don't see any indication that this is an S3 server, so this is probably not directly talking to an S3 Booker. And what we see is that we posted to this export CSV endpoint, and we got a download URL, which is probably getting parsed by the JavaScript. So I imagine if you see down below there, you can see that this is a link to an S3 Booker. And this is one of the pre-signed links for a GET request. And you can tell that this is an S3 one because it will have this X, AMZ content type kind of headers here. And you can see everything, and then you can see the signature as well. So this is a signed S3 signature. And I'm going to just show you what this is going to look like. It's just going to basically get this export CSV. Maybe I can copy the link into the browser. It's probably going to be a lot better. And if you try and access data that you don't own, because this is a signed link, for example, I'll just change it to like 7 or something, Amazon's like, no, we did not sign that. That's the wrong signature, and we cannot give you access to that. And the same thing will happen if you try and do like a post request instead of a GET request. This is generally what you're going to be greeted with, is like, nah, we actually signed something else, so that you can't do that. But if you try and access your own data, it's going to be like, yep, that signature matches, and that's all good. So that's generally what happened. What we can kind of infer then from this feature is that the server probably posts the CSV data themselves to this S3 Booker, and then just gives you a link to access it yourself from the S3 Booker, which is just to save a bit of data. And what's interesting is that it's stored in the /exports folder. The /exports folder, we can remember, is going to basically store all the CSV data. And this stuff is quite sensitive to organizations. They really don't like when stuff like the activity log, or when like their team activity or like team logs are leaked. So companies are particularly sensitive about these CSV endpoints. So we want to find a way to leak this, basically. So we want to find a way to attack this, because this is going to show a lot of impact. And you can be like, oh, look, there's PII in this. And then we get the nice little payout there. So we're really hoping for that. Now let's try out the other feature. So we see this is, I don't know, I'll rename this, and I'll call this like CSV export. So that's how the CSV export works. It's generated and presumably stored on this S3 bucket forever, because data is usually not deleted from S3 buckets. So we can keep that in mind, and then we'll try out the next feature. Just going to be upload a profile picture. Go into here and just select a random image here. I'll go into here and I'll upload the avatar, and we'll just break down the flow for this. So first, we have this endpoint called generate upload URL. That's probably going to return the policy, I presume. It's going to return the policy. So we'll just send that to the replay tab with F3. I'll just show the response to confirm that this is true. And we have an upload URL. So this one doesn't look like the one that I showed you, but I'm pretty sure this actually does the same thing. It's just a little bit of a simpler signature. So we're going to forward that. And then we get setAvatar.php, which is another one, and it's posting URL. So we'll also send that into the replay tab like so, and it's going to give back another S3 URL. Now, this heavily relies on S3, which is a great thing, because it's probably going to mean that there's S3 misconfigurations here. Now that we've kind of walked through each of the features, we can see here this generates the upload URL. Let's see what this does. This generates from what I can see, this is a upload URL. So I imagine this is going to accept a post request instead of a GET request. And it's in the /avatars directory, which is pretty nice. And then it's going to be available at /avatar.png. And it's signed as well. And you can see the key right here as well, /avatars. For some reason, it's not JSON encoded. It's not JSON escaped for some reason, which is really annoying. But either way, that's going to be the key as well. So we'll call this something like generate URL. And we can see this is a very typical S3 response as well, actually. And then we have this one, which takes in the S3 URL. And we see that there's actually no signature here. That's interesting. There's no signature for this. And then when we send it in, we get back a request with a signature. I've often seen this happen a lot on these servers, whereby first of all, there's a feature to upload something to an S3 bucket, and then there's a feature to actually set that S3 bucket key as whatever kind of parameters on a different object. And the reason this happens a lot is because if you had the person actually set the URL, the S3 URL, then it would expire after about like an hour. It would expire. That's not good if you want to have something like an avatar, because you want it to be continuously available. So generally what they do is they have the user upload some kind of URL, and then they auto sign it anytime someone wants to access it. And I presume, actually I'll set this as a name first. I'll set this as set avatar. I presume that there's a feature that's going to allow us to actually access our avatar as well. So I'm going to go back to the proxy. I'm going to queue the request again, and I'm going to get my avatar. Then we go back here and we have get avatar /php. So I'm going to do that, unfreeze the thing, and this is going to respond with the signed URL. Now what we can kind of infer is that if the signature is different each time, that means the server is re-signing it. So we're going to first of all get this signature. We're going to refresh it, and we can see that the signature is different. This means that the server has re-signed our URL. So what does this mean? This means that this is a great attack scenario for us, because this is now going to sign whatever URL we give it. So if we manage to inject some kind of malicious URL into it, then we should be able to get the server to sign whatever we actually want it to. And I'm just going to call this get avatar instead. So even if this URL wasn't returned in this request, we could fetch the other request, get avatar, and actually get the URL again by getting the server to sign whatever payload we want to. And so the obvious attack pattern would be right here, the URL that we specify. What if the server isn't actually verifying if this belongs to us? Maybe this belongs to someone else entirely. So then we check the obvious thing first. We check whether we can do some kind of IDOR for this thing. What if we can set someone else's profile picture as our profile? And we see that that actually worked, and the server gave us back a signed URL. This is significant. So we've established that the server is not protecting other users. But what sometimes does happen is the server will limit you into a specific folder, like the /avatars folder. So for example, everything like this will work, where the star here means that basically you can put anything after this avatars, and the server is just checking that this thing starts with this. So we can verify this, see that it's still signed that. So at the very least, we know that we can specify any avatar for any user. That's already a good thing. Now, what if we try and sign the root directory? We get an internal server error. Maybe if we try and sign something that we don't exist, that doesn't like A, and we actually do get it back. So we get /A, and we get a signature. Now we can check if this works by, that's going to be really annoying to do. Hold on. We can check if this works by going here. Maybe like create something here like this. We can come over here. We can just escape all the stupid backslashes. Here. I think that should be everything. Escape the backslashes. Go into our browser here. You can see the specified key doesn't exist, but we did not get a signature rejected error, which is the main thing. We did not get an error that rejects our signature. So now we have found the vulnerability. The vulnerability is the server will now sign any path that we give it to this feature. And now, how do we escalate this? How do we escalate this to show impact? Well, remember that CSV data I showed before? Well, where is it stored? It's stored at /exports. And now we want to find a way to target this. For example, we can get the CSV export. You can see the /exports directory. Now, showing impact is going to be slightly difficult, and the reason is because you can see this is an actual an user identifier. So that means it's going to be stored under a user ID, which is a little bit annoying. So there's kind of two ways to show impact. One is to use that crawler data that I mentioned before. Well, actually, there's three ways. One is to use that crawler data that I used before, so using OSINT, and this is the most reliable way to do it. However, you probably won't get a critical for that, just because the amount of data you can get is highly limited. by who's actually allowing these antivirus crawlers to scan their computer and stuff. But you will normally get a high for it. How do you push to critical? Well, you're going to have to find some kind of oracle, some place where you're actually able to actually enumerate user data reliably. So one of the places you can try is to see if directory listing is enabled. So I mentioned those folders. Maybe signing something like export slash will actually allow you to list the bucket. This is very unlikely now. Unfortunately, this was kind of patched a while ago, and the S3 people got a bit smart on this. So this is probably not going to work, but it's still worth a try because this is kind of a free critical vulnerability. I'm going to try it like this, go into this, and you'll see that the specified key doesn't exist. Again, even though this is a directory, it's considered a key in S3, and exports will probably be the same. So listing is generally not going to work anymore unless you're attacking an older target that's using an older version of S3 buckets. So how else are we going to show impact? Well, the way that I usually like to show impact is using, when I can't find an oracle, which on this website seems very unlikely that there's an oracle to list some kind of exports, is by just using crawler data. And first of all, you actually want to make sure that you can access your own exports and stuff. So what I would do is I would copy something like this on an account that I control. Please don't try and access user data with this first of all. And then I would go like this. I would put it export.csv. I would make sure that's correct. I would take this URL into the toolbar again here. I would come here, I'd unescape the URL as we did before. And then I'll make sure that I can access at least my own data with this that I'm not supposed to access. So using this thing, I'm going to come here and you can see export downloaded. So that's very nice. And the same thing will happen if we get avatar. It's going to try and load it here. You can actually copy it from the image as well, because it's going to try and put it into the image source like this. It's not going to load because this is a CSV file, not an image. We can still do it here. So you can show impact that way. So make sure the first thing you want to do is to make sure that you show that the triager can access your own data, which is what I would put in like the steps to reproduce. I would give them this and I'd say to access my data. But we obviously want to show greater impact than just our own data. We want to show impact in a wide range of customers. So now I'm going to show you how you can actually use that crawler data in order to basically upgrade your severity to at least high. And the way we're going to do this is using a tool called way more URLs. And we're going to just find the bucket, right? And obviously my bucket isn't going to have any crawler data on it, which is because it's just new and the service isn't used by anyone. So there's not going to be any crawlers that go on this bucket. However, if we go to like a more popular bucket, like this Asana user private US East 1, then we should be able to get the crawler data. Now remember, the S3 URL looks like this. And you can also use the reverse proxy version of this if you want to. This will also work. However, because Asana doesn't have that, we're just going to use the actual normal S3 URL thing. So we're going to go to HTTPS, like this, /Asana user, let me see again, it's Asana user private US East 1.s3.amazon aws.com. This, I'm going to visit it and it's going to say access denied. That means that the bucket exists, right? If it says access denied, that means the bucket exists. Versus if we enter a bucket that does not exist, like this thing, it's going to say, oh, we don't exist. That's nice because it gives us that verbose error message that's going to allow us to enumerate buckets. And now, with this URL, we can go to this tool called, I'll show you now, called way more URLs. So what you just want to do is put that Amazon AWS header inside of there. And when you enumerate this bucket, I'm just going to hit that. It's going to start getting a lot of sources for me. And it's going to get, and this is going to allow me to basically enumerate those user keys. And this is how we're going to show impact. We're going to show that we are actually able to enumerate user keys on this bucket and that we are actually able to steal user data. For example, you could like take this bucket, you could grab like, don't access user data, but say like I could access over 2,000 people's private attachments. that's good impact on this company, especially if it includes those CSV exports. Then that's going to be a very good way to show impact. Okay, so just to finish, it can take a little bit of a time for some of the bigger domains, but the more times it takes, the better, because that means you have more user data to show, right? So we have 1,541 attachments for this one. And now if we just do like cat URLs, url.text, like so, we can find this thing right here. And you can see there's a lot of there's a lot of URL keys. And you can see every single one of them is one that we could potentially access if I had an S3 Booker read on Asana, by just copy pasting this file here, going back into Kaido, going into this, doing /assets, like so, and the server will happily sign that for me. So if I had a Oracle where I could do this on Asana, I could access 1,500 attachments. And the great thing about this is that normally on S3 buckets, files do not disappear. So even though you delete something in let's say there's a way to like delete the profile here or like change it, the great thing is that normally the files will not be deleted from the S3 bucket. Most servers don't do that. They're not bothered with it. And that's phenomenal, because we could access files that the company tried to delete from the Asana servers, but that are still in the S3 bucket. So that's a great way to exploit it. And yeah, that's pretty much the example for today. I showed you how these features can interact with each other, how they can work together to create vulnerabilities, how these companies often use one S3 bucket just to store everything on just one server, and how that can basically lead into someone being able to steal very sensitive files through a feature that's honestly not very sensitive by itself, like uploading a logo or an avatar or whatever. And I also showed you how we could use crawler data to escalate impact when there's no way to reliably enumerate user keys through some kind of oracle. And that should give you at least a high, but if you're able to find the oracle, you could move it up to a crit. So an oracle, like a way to list every single user's like CSV export file key on S3. So some kind of way to do that, which doesn't happen a lot, but maybe the bucket listing is enabled, which it probably isn't, or the server has a way of actually doing that. Some kind of, you chain it with some kind of IDOR that exposes that kind of information to you. So it's very target dependent, but you could find that way as well. And yeah, I hope you enjoyed this video covering S3 buckets. I know it's very similar to my last video about S3 buckets. However, I've been having a lot of success with this technique lately, and I really wanted to kind of do like a revamp of that previous video, just to kind of get the point across and look at it from a kind of a different perspective than my last explanation video. And I hope that it was useful to you as well. Now, if you didn't like this video, then you're not going to be happy, because next video is also going to be about S3 buckets, and it's going to specifically dive into that modification aspect of the bucket. And I'm going to do a little bit of research on this before I post that video. I'm going to read a lot of those AWS documentation that I told you, get a master's degree in AWS. But yeah, I'm going to look to that, and I'm actually going to talk about my first critical vulnerability, which I found, and that's going to be very cool. So I'm going to talk about that and how we can potentially modify other users' data on an S3 bucket, and how we can show impact on that on the platform in very consistent ways across a lot of programs that I've seen. So I hope you're excited for that video. And if you did enjoy the video, then be sure to leave a like and subscribe to the channel. And if you didn't like something, or if you wanted me to change something, or if you have some feedback, then please leave a comment in the description. I try and always read them, so please leave a comment, and it always warms my heart to read your comments. So yeah, do be sure to do that. And you can also find this lab in the description. You can find this lab, the previous report that I have disclosed in Asana, which is quite similar to this one. It just happens to cover like WebSockets and stuff instead. And yeah, and that's it. Thanks for watching, and happy hunting.